In this lesson, we're going to explore integration by parts, a powerful tool in calculus for evaluating integrals. We'll focus on the integral of x times e to the power of negative x dx. We'll start by selecting our functions u and dv, then we'll differentiate u and integrate dv, apply the integration by parts formula, and finally evaluate the resulting integrals, finding the solution step by step. First, let's remind ourselves of the integration by parts formula. Integral of u dv is equal to uv minus the integral of v du. Now on to step 1. Selecting our functions u and dv. We want to choose u and dv such that the integral of v du is simpler than our original integral. Let's assign u equals x and dv equals e to the power of negative x dx. This choice allows us to reduce the power of x upon differentiation. Moving to step 2, differentiating u and integrating dv. When we differentiate x, du becomes dx, and when we integrate e to the power of negative x, we obtain v equals negative e to the power of negative x. Now, let's apply the integration by parts formula. We substitute the values of u, v, du, and dv into our formula. Integral of x times e to the power of negative x dx is equal to negative x times e to the power of negative x minus the integral of negative e to the power of negative x dx. Let's simplify our expression. Negative integral of negative e to the power of negative x dx is the same as plus integral e to the power of negative x dx. Finally, let's evaluate the remaining integral. The integral of e to the power of negative x dx is negative e to the power of negative x. In addition to x e to the power of negative x, our final answer becomes negative x times e to the power of negative x minus e to the power of negative x plus our constant of integration, c. Remember, we add c to represent the family of all antiderivatives. In summary, we have solved the integral of x times e to the power of negative x dx using integration by parts. Step by step, we chose u and dv, differentiated u and integrated dv, applied the formula, simplified the expression, and arrived at our final solution. Integration by parts is a handy technique for dealing with complicated products of functions in integrals. With practice, selecting u and dv becomes more intuitive.